Okay, good morning. Welcome to
Family Math number 511.
FamilyMath511. So these are our, we made a torus and a sphere using different metrics, which are different ways of measuring distance. And so this one here is what our normal torus looks like, and what we would normally talk about as a sphere. So we're starting a long project, maybe a month or two long, on 3D printing today. And the first thing we talked about was distance. And since we had the torus and the various different torus and spheres here, I think these are going to be good examples. So when you and I talked distance this morning, the first thing we talked about was how you measure it in a plane, starting from the origin, going to some point xy. And can you explain what you do in this situation?
Well, there's a standard distance, so the distance from the origin to xy is the length of this line segment between them.
Yeah.
And so to find that, you can use the Pythagorean theorem. So you go over x and up y, and you get this right triangle.
Okay.
Here that is one side x, one side y. You use the Pythagorean theorem, and this side here is the square root of x squared plus y squared.
Okay. Cool. So let me ask you a question that we didn't talk about this morning, but it just helped you understand the standard way of measuring distance that gives us, a nice torus like we're used to seeing, and a nice sphere like we're used to seeing. I'm going to put that inside since they tend to run away. So sometimes you might see some fairly complicated equations, like an equation that looks like this: x squared plus y squared equals 1. But you just learned that you measure distance using in the normal way by saying the distance from the origin is the square root of x squared plus y squared. So this equation kind of reminds you of this. So what do you think the graph of this equation is going to look like? What is this equation saying in words?
Well, it says that x squared is like the distance over x squared plus the distance up y squared is 1.
Right. That's what it says. But what else? Let's try to understand it more comprehensively. Here's our distance formula. Here, what is this distance telling us here? The square root of x squared plus y squared.
So it's telling
about
us
this point.
About how far that point is away from the origin.
How far that point away is from the origin. How does this equation relate to this equation?
Well, you sort of squared. Like if you said this was equal to 1, and you squared it, you'd get this equation. Okay,
and so what would that be saying about the points that are part of the graph of this equation?
So maybe this is all points that are a distance of 1 away from our origin.
Okay, so here's our distance formula. I square it. This tells me all the points that are a distance of exactly 1 away from the origin. So what does that graph look like?
That would be a circle.
That would be a circle. More specifically?
Circle centered at the origin of radius 1.
Yeah, circle centered at the origin of radius 1. Now what if I change this to be x squared plus y squared equals 2? How would my circle change? What would the center be? What would the radius be?
So the center would still be the same. The radius would be 2 instead of 1. Or, no, the radius would be the square root of 2.
Why?
Because here, to get from here to here, you'd have to have x squared plus y squared equals the square root of 2.
Very good. So in this one, the radius is the square root of 2. So in other words, the equation for a circle centered at the origin is x squared plus y squared equals r squared. So you have to remember to take the square root. But this is what it seems like a very complicated looking equation. Actually, just relates very nicely to the distance formula. Okay. All right. So let's move on.